Okay, so today I'll be making trigonometry very extremely simple for you. And right now we'll be just starting, and I assume that you know the basics of trigonometry and just writing the formula for you. It is actually this one that for first I'm writing sine theta, the cos theta, and the tan theta, and it is somewhat like this as okay. So here we get all the formulas in one line. You just have to just memorize these formula, and trigonometry will be like very simple for you. So right now we'll be just seeing how to apply these formulae, and yeah, just write. And the basic is that you should know that the P stood for perpendicular, the P is perpendicular, and the B is the base, and the H is the hypotenuse. Okay, so that is the thing. Now we'll be seeing how you can see all of them in triangles, and I'll be telling what this trigonometry really do is that in trigonometry in the schools which you need to study is only about two triangles. That is the 30 60 90 triangle, where this angle is 90, this is 60, and this angle here it is 30. Okay, and there is one more triangle. It is the 45 45 90 triangle, which I'll drawing just here for you, where this is 90, this is 45, and this is also 45. Now what do we see in trigonometry? That you see that if you get provided in the questions, basically I am talking about right now, that in trigonometric questions you're provided like this, that they give you a triangle. Let's assume that it is a 90, 60 and a 30-degree triangle, and what they actually ask you is that you have the length for this side, this one. Okay, so let us assume that the side is x, and you will be just provided with these, and they can ask you the measures of the side. Let's just name this triangle as ABC, and they provide you the side of BC, and they can ask you the side of AB and AC. So how can you find these sides? Just by knowing the angle, right? So now we'll be seeing, and actually what is there, that you see a 30, 60 and a 90-degree triangle. It goes somewhat like this, and you can see that the ratio of all the sides are typically, they are somewhat same. So let us assume that it is a small triangle, and let us assume that this one right here is a big triangle denoting as B. And if you divide this side like ABC upon ABC, and this is EFG. Okay, now if you divide AB upon CB, the answer will be something. Okay, let's call it X. And if you divide EF by GF, your answer will be the same. Okay, so that is the kind of ratio you see in a 30 60 90 triangle, and as well as the 45 45 90 triangle. Now we'll be seeing what are these ratios and what are the values of these ratio. And let me tell you, the ratios of the 30 60 90 and the 45 45 90-degree triangles, they are same for every triangle. Okay, and let me get it easy to memorize you. And first we'll start off by, to memorize you the ratios, we start off by making a 60-60 degree triangle which is equilateral. Okay, so just now, as I have drawn the 60 degree triangle, let us mark it for you. This is the 60-60 triangle, and if you draw a perpendicular bisector, so if you draw a perpendicular bisector here like this, okay, these angles are 90. Now what we will see, that if we assume that the equilateral triangle has sides of 2 each, okay, they are having a side of 2 each, and then if we divide it, what will we get now? Okay, so we'll be taking this triangle, let's call it ABC, and so this side, it was 60 divided in half, so it will become 30. This was 60, no division, it will remain 60, and this has become 90 because it is a perpendicular bisector. Now what we can notice here, that this is a 30, 60 and a 90 degree triangle. Yes, so now if we see the sides, what will we notice here? Yes, okay, so let's make it clear for you some. Okay, so this is a perpendicular bisector, so the value of BC will be 1, okay, as it is dividing both these two. And the value of AC, like, let me just write it here for you, like BC and then AC and then AB, right? Let me rub this triangle. Okay, so now what we'll be writing here, at BC, the value of BC, we have found it to be as 1. AC value is 2 because we haven't done any division, and we'll find the value of AB. And I think that you must be aware of the Pythagoras theorem, which states that base square plus perpendicular square equals, okay, let me just grab the board and shit for you. Yeah, base square plus perpendicular square equals to the hypotenuse square. Okay, so the base here is this line right here, which is AB. So we don't know the base, we know the hypotenuse here, which has the value of 2, and we also know this. What is it? Yes, it is the perpendicular. So what we write it here as the base square, as we don't know what is the base, plus perpendicular square. Our perpendicular is 1, so 1 square is 1 anyways. So, and the 8 square is 2 multiplied by 2, it is 4. And if you shift this side, the b square will become 3, and the value of b will become root 3, right? So here what we have found out, that the value of AB is your root 3, okay, it is root 3. So what we have found out the value of AB to be, it is root 3. Okay, so I think now I have made it clear for you to just memorize all these things in a 30, 60, 90 triangle. Okay, yes, so I've made it very easy. Now we just see the sine theta, the cos theta and the tan theta. So what are basically all of these? Okay, so these are ratios, just simple as that, they are ratios. We'll take just sine theta for example, like we write sine equals perpendicular upon hypotenuse, right? So in a 30, 60, 90 triangle, what did we find out? Okay, so we'll be taking out the value of all the trigonometric ratios from what actually we have learned previously. Okay, so now I'm drawing a 30, 60, 90 triangle. Okay, it may not look like, but let's assume for the time. Now this is 60, this is 30. Okay, yes. So what we had found out that this side it is 1 because it's like dividing, and the hypotenuse was 2, and the perpendicular was the what was the perpendicular? It was, yeah, root 3. Okay, 30, 60, 90 triangle, the sine theta is perpendicular upon height. So the value of the perpendicular is root 3, right? So root 3 upon what is the hypotenuse? It is 2, right? So what we have found out just now, that the value of sine theta in a 30, 60, 90 triangle is root 3 by 2. Okay. So similarly, we will find out the values of, yes, we'll find out the values of cos theta. So the cos theta, it's here. So the cos theta is base upon hypotenuse. Okay. So what is the base here? Okay, so the base is 1. We write it down as 1. What's the hypotenuse? Yeah, it's obviously it's 2. So the value of cos theta in a 30, 60, 90 triangle is 1 by 2. Okay, so we have written here. Now we'll be finding the value of tan theta. Okay, so tan theta is, okay, so tan theta, it is perpendicular upon the base, right? As I told you, perpendicular upon base. So what is the perpendicular? It is 2, obviously, and the base here is 1, right? You can see. So the base here, it is 1. So the value of tan theta in a 30, 60, 90 triangle, it is 2. Okay. So if now I've told you, and yeah, just one thing, there is one thing known as the inverse ratios, and actually I've told you about the sine, cos, and the tan. Now what we'll be seeing is that if I was talking about inverse ratios, so 1 upon sine is h by p. So the thing will be Cossack. Okay, so Cossack is basically 1 upon sine, right? And we'll be looking at another ratio, and that ratio is 1 upon cos. Okay, so 1 upon cos, it is also known as sec. And what did we study about cos? It was the base upon hypotenuse. So as you know, just reciprocate it. It will be hypotenuse upon base. And we'll be seeing about the tan. So I'm writing here tan. Oh, sorry. Yeah, so 1 upon tan. We also call 1 upon tan as cot. And what did we know about tan? Okay, so tan is basically your, so what was the formula for the tan? Was perpendicular upon base. So cot will be base upon perpendicular. It's really easy. Okay, so now we have talked about 30, 60, 90. Now we'll be talking about the 45, 45, 90 degree triangle. Okay, so let's assume that the sides having 45, their value is 1. Okay, so this will be 1, this will also be 1, and this side, which is the hypotenuse, automatically this side will become root 2. Okay, and as you calculated the values for 30, 60, 90, you also calculate the values for 45, 45, 90. It's just really easy. Now just some tips, and the thing is that please don't be confused with 1 upon sine and the sine inverse. These are not same, okay? These are not the same, okay? Just remember it. Actually, 1 upon sine is Cossack, as I already told you. And the sine inverse, the thing is that it is just the inverse of what we do in the questions, okay? So we know the angle and we need to calculate in the questions, like we know the angle and then we need to calculate the distance. Now sine inverse is basically that we know the distance, then we need to calculate the angle, okay? So the sine is, so let me make this clear for you. Sine is angle to distance and sine inverse is distance to angle, okay? So that was all I had to say. Okay, so thank you, and please hit like, subscribe if you enjoyed this video and found it to be useful. Thank you.